Hello and welcome to today's Partner Web Conference. This is Fast Track Dynamics 365 for Finance and Operations Enterprise Edition Tech Talk. Today's topic, Dynamics 365 for Retail POS Extensibility Deep Dive. Presenting for us today from Microsoft, we have Program Manager Mugunthan Manny, Senior Software Developer Roman Vaktarov, and Software Developer Luke Graham. So without any further delay, Mugunthan, over to you.
Yeah, thanks, Jancy. Okay. So thanks everyone for taking your time and joining the session. In today's session, we're going to talk a little bit more about how to extend POS. In our previous section, we went over the overview of what's new in the Retail POS for the spring release. So in this session, we'll do a deep dive on some of the POS extensibility topic. So the main agenda for today is first we'll talk about how to create a new view. So basically a new view means when you're doing some new feature and you want add a new screen. For example, you're implementing your own warranty feature or your own case management feature, something in POS, and you want to create your new view. So this example or the demo will show you how to create a new view in POS, and then or even link it to operation. So we have some real world sample. We'll go over that code and show you how you can create a new view. Next topic will cover how to extend an existing view. Say for example, we have our show journal screen or the inventory lookup screen or a pickup receiving screen. In those screen, if you feel for my own business scenario, I want to add a custom column. So maybe let's take a sample scenario in the show journal screen. You want to add a new custom column. Say for example, your business model says hey, I should return the transaction within 30 days, and you want to show that remaining number of days as a custom column in the show journal screen, so that your cashier knows hey, when I click a particular row, it's already out of bounds in the return time window, or it's allowed. So can you want to add that custom column and show that information? So we'll show you how to add a custom column in our existing view, and then also we'll show you how to add a new app bar button. For example, in our POS, we have a pattern the grid, and then the bottom will have app bar, but app bar where you can add your own button. So we'll walk through how to add a custom app bar button on our existing view. Okay, and the next we'll cover how to create a new operation. When I mean new operation, any button you see in POS, it's tied to a AX operation, a POS operation. So we'll walk through how to create a new operation. For example, any new functionality you do in POS, it's kind of like operation. Okay, so we'll walk through what is the request handler or what is the factory required for the new operation. Okay, so for all of this topic, we'll show over the code and use one of our live sample, the store as, and then we'll walk through end to end on this one. And then next we'll talk about how to create a trigger in POS. Trigger is something before you do any pre and post. Before you do any operation, we have a pre and post trigger. Say for example, before adding item to cart, you want to do some custom operation, do some pre-validation, or after the item is added, say you want to, for your own business scenario, you want to change a price, right? So it's kind of a post scenario. So for all of our POS operation, you can do a pre and post trigger. So this sample will walk through how to register a trigger and how to use it in the manifest. So we'll walk through that. Okay. And also in addition to the operation trigger, now in the new version, we added some more enhancement, for example, after you capture a serial input and then you want to do a validation, there also you can put some triggers and do the validation. So we'll walk through that. And the last other new concept we introduced in this POS spring release is the overriding a POS request handler. Previously in the older way, there is no concept of kind of overriding our request. Mostly what you will do is you will take our code and then you will do some inline changes, right? With the new model, we introduce a concept called overriding a POS request handler, where you can override a particular request. For example, before making a payment, we do a bunch of steps, right? When you click the pay button, it does 3 steps: authorize, or calling the payment gateway, and then confirming the transaction. So each has multiple steps. So we'll walk about if you want to override a particular full logic, saying hey, for authorized payment, I want to completely use my own payment connect, I don't want to use the Microsoft standard code, then you can override the request. So in this sample demo, we'll show how to override a request. Okay, so that's a brief topic we're gonna see it today. So I will hand over to Luke to show the demo of how to create a new view or modify an existing view. Yeah.
Thanks, Bonnie. All right, so I'm going to talk a little bit about how to create a new view. So let's get started here with the basics. Each extension view will be defined in the manifest under the create and then views node. There's a collection where each extension view will be added. Each extension view manifest item will contain a title for the view, the page name, the phone page name. This can either be the same as the page name as shown on the right here, or if you wish to have different markup for the phone form factor, you can also specify a different phone page name that will be loaded when POS is running on a phone. In addition to that, we need to specify the view directory that the phone page and the regular page sit in, and the view controller path. The view controller path is the path to the module which will be used as the view controller for that page. Each of these extension view controllers should inherit from extension view controller base in order for them to be loaded and to work in POS itself. So in addition to the extension view controller base that each of the extension views will use, we also have the Posse UI SDK library, which is the library that we use to expose some of the controls that are used within core POS, and then each extension view can use these to maintain a consistent look and feel with the rest of the application. So the way that this works is each control consists of a class in the UI SDK that derives from the POS control base class, and then it also has a corresponding knockout binding. These controls will be imported from Posse UI SDK controls, and then the control name is the module as well. And then the knockout binding that corresponds to that POS control will be the control name, but prefixed with MS POS. And we'll go through some examples of how this works when we dive into the code here in a minute. All right, so with that, let's actually dive into the code. Okay, so I guess to get started, we'll show you the application running for the store hours sample. So that button there was going to run a custom operation as defined in AX, and then here you can see our extension view for the store hours sample. So you can see on the left and on the top here, we're using the header split view to maintain the same look and feel as other POS views. And then we also have a data list control here showing the different store hours. So that is kind of what we're looking at with the store hours sample. And then I'll dive into the code here and kind of walk through what exactly the code is doing. So going into the store hours view, so you can see here that we are importing a number of different controls from the Posse UI SDK. So here's the control for the loader, for the data list, and the header split view, and then we can see how we use them below. Also, we can see that it's extending knockout extension view controller base, which is just kind of intermediate class that we've created in the samples to help for knockout based views. But if we look at that, we can see that that derives from extension view controller base. So we're still inheriting from view extension controller base, which is necessary in order for the extension view to fit in with the POS navigation framework and to make sure that all of that works smoothly. So, but back to the implementation for the store hours view. You can see that we have the view model, and then we have three controls as member variables on this store hours view. All of these are instances of controls that are imported from the Posse UI SDK, and you can see in the constructor we're initializing them one after another. So if you look here, we're initializing the loader with the observable to use for whether or not it should be displayed. We're initializing the header split view with the title, and then we're initializing the data list down below with the columns to use in the data list. So for the data list, you can see that we're specifying for each column the title of the column, the ratio, so this is going to be the percentage of the total data list width that this column occupies, the collapse order, so this will be 1 through n, where n is the number of columns in the list. So the lower the collapse order, the earlier the column will be collapsed if there's not enough room to display all of the columns side by side. And then we have this compute value function here, which takes the type of the row data and it returns the text to be displayed in that row for that column. So switching back to the title here, we can see that it's using context.resources.getString. So what this is going to do is get the localized string resource for this column so that it'll handle all the localization needs so that the extension can run in different languages without any issues. And so in addition to the resource manager that is provided in the context for the view controller will also receive application framework components like the POS runtime, the extension logger, the extensible enumeration manager for handling extension enums. It'll receive the extension package information and the navigator, which can be used to navigate to different POS views or to different extension views as well. So that's kind of it for this view. If we switch to the view model, we can see first it's using the data service requests and entities up here that it's importing. So these are going to be the auto-generated requests and entities based on the retail server APIs and the CRT data model generated using the proxy generator. And then scrolling down, we can see we've passed the extension view controller context into the view model and saved it. And so you can see here we're using the runtime to execute a request to get the device configuration from POS. And then after that's complete, we're using the runtime again to execute our custom data service request to get the store hours based on the store number that was returned from the device configuration. So all of this done using the POS runtime, both the existing requests under POS API consume, like get device configuration client request, and then the custom data service requests generated from the proxy generator, all run through the POS runtime here. So let's see. That, and then you can see down here we're also using the logger to log an error if for some reason the retail server request were to fail. That way, we have all of the instrumentation and tracing data to be able to troubleshoot later on. So that's really it for the store hour sample. Hopefully it's fairly straightforward there. So I'll switch back and we'll talk a little bit about extending the existing POS views here. All right, so starting with custom app bar commands. App bar commands provide a way for extensions to add a new button to the app bar on various POS pages. This is supported currently on 4 pages, those being simple product details view, customer details view, search view supports both the product search app bar and the customer search app bar. We have different classes and different functionality for those app bars, even though they're on the same page, since they'll receive different types of data and different information, and likely there would be different kind of execution and functionality based on either product or customer. So we've separated those, and then we also have show journal, which I'll dive into here in a minute. So those were what was released initially in 7.2. Coming up here in our 3rd app update, we'll also add support for custom app bars on the customer add edit view. And so then we'll continue to grow the number of pages that supports this based off of our backlog. So each of these app bar commands is defined in its own module, and each of these should inherit from extension command base class for the page that it is to be added to. So all these page-specific base classes inherit from extension command base, but they add additional functionality specific to the page that command will be added to. All right, and so now to talk just a little bit about custom list columns before switching over to the code and the samples for show journal. So custom list columns allow extensions to override the default column set on the existing POS pages in order to add, remove, or reorder the columns that are displayed. This is currently supported on 3 pages. The search view, so again, both product and customer search, but again, these will be slightly different in the way that they're implemented, and they'll have different nodes in the manifest, since again they're kind of different functionalities on the same page. And then we also have inventory lookup view and show journal view supported for the custom list columns. Each list that supports custom column sets has its own node, like I mentioned, where the column set creator module will be specified. So based on what's in the manifest, we'll load that module and the custom column set. These modules should have a single default export, which is a function that returns the collection that contains the new set of columns or the custom column set. All right, so now with that, let's switch back over to the code. Okay, so just to briefly again show the functionality before diving into the code, we'll go to show journal here. And so you can see we have date customized, this is one of our dev sample columns, and then receipt, again customized here, and total. And then we also have operator ID, which is again customized. You can see with the sample string there that it's not core functionality. And then the register and the type sales. So also you can see that if this expands, then in theory, well, I guess if the display was a little wider, the operator ID, the register, and the type would also be displayed on the top here, but because there's not enough room to display all the columns, they won't show side by side, but these are collapsing based on the collapse order on the column, which I'll show once we dive into the code. But this is kind of the dynamic functionality of the data list here. So in addition to the customized list functionality on the show journal page, we also have the download document command for our dev sample. So you'll see right now, because we have a transaction line selected, the button is enabled, but if I unselect that, we're going to see that the document is now disabled. If I go ahead and reselect it, command is enabled again. So now to dive a little bit into the code and how that works. Go here to our sample extension project, show journal. We'll start with the transaction list columns. So these are going to be the columns that we just saw displayed there. So you can see that we have the export default of a function that's returning a collection of custom columns. So these custom columns, because it's the show journal page, we're going to use show journal transaction list column, which is imported from Posse API extend views show journal view. If we dive into the declaration for that, we can see that we have show journal transaction list column is extending our iCustom list column with the entity type specific to show journal view and the transaction list. So each of the grids on the different pages will have their own column type, and so the custom column sets for those grids should extend or should return the interface based on that specific type for that grid. So we can also see here that this factory function that we're returning receives the columns context as a parameter. So this columns context is going to be similar to the extension view controller context that we just saw for extension view controllers, and again is going to contain all of the application framework functionality that can be used from the extension. So for columns, probably the most useful of these is going to be the resource manager, but again, it also has access to the logger and other application functionality from within the factory function. So to talk a little bit about the values that are here on the custom list column interface, we have the title, which is what we saw up on as the column title. It's fairly self-explanatory, but so here we haven't done it using the resources. However, that is a best practice, is to use the resource manager to get the column titles based on the current locale if you're planning on developing an extension that'll be run for different languages. We have also, the next field is the compute value. So this is basically the field that is, or the method that gets in the row data from the framework. So in this case, because it's show journal, it's going to be a transaction, and then it should return the text that is to be displayed. So for the date customized, you can see it's taking advantage of another functionality that is exposed from Posse API, which is this date formatter. The date formatter itself can be imported from Posse API consume formatters. We have a number of formatters available in that module, and these should help you to utilize some of the formatting functionality that has already been developed as a part of core POS. So next, after compute value, is the ratio. So again, this is going to be the percentage of the width that this column should occupy. So you know, the sum of all of these should be 100, and that should be it's critical for us to dynamically size the columns that this ratio is provided and accurate. Next, after ratio, is the collapse order field. So this is telling us which order we should collapse the columns in. If, like we had here, that the grid or the data list doesn't have enough width to show all of them side by side. So that should be 1 through n, where n is the number of columns in the set. The highest collapse order value will be collapsed last. The column with collapse order 1 will be the first one to be collapsed if there's not enough room to display all of them. Then finally, after collapse order, we have the minimum width in pixels for that column, basically saying if it's less than that, then we will need to specify it'll start to collapse based on the collapse order in order to make sure that they all fit and display in a legible way. And then finally, down here is you can see on the total column, we're taking advantage of our last optional parameter on the custom column interface, which is whether or not the column should be right aligned. So if it's true, it'll be right aligned. If it's not specified or if it's false, we will left align the column. So that's kind of the deep dive there into the custom columns. Now to switch over to the @bar commands. So to start with that, I'll switch. Oh, actually, this is what we want. So starting with the module for the base class for extension @bar commands, which is extend views @bar commands. So we have this base class for is extension command base. Extension commands should not directly inherit from this base class, but instead they should inherit from the base class specific to the view where the extension command is going to be added. But all of those base classes for the specific views that we expose on the API will derive from this extension command base class, which provides a lot of the critical functionality for the @bar command framework. So starting kind of with the fields that are exposed on this extension command base, we have extra class, which allows you to add extra CSS classes to the element. This is typically used to specify the icon for the @bar button based on the CSS class, and we'll see an example of that when we look at the sample for show journal. We have the ID field for the @bar command. So this will be the element ID of the @bar button that is added. And then we also have the label, which will be the label that is displayed on the app bar for that app bar command. So the extra class and the ID must be set in the constructor, and the label can be set either in the constructor or in the initial init method for the command, which I'll talk about in a minute here. So in addition to the fields, let's talk a little bit about the constructor for this extension command base and for all the extension commands in general. They will all receive the context again, which is extension command context, and so this context will contain all the functionality to interact with the POS framework, as well as, in this case, it's receiving this message channel object. The message channel really does not need to be consumed by the extension commands themselves that are defined in the extensions, but it is something that we take advantage of in the base class for each page in order to communicate back and forth with POS, but we have abstracted all of that communication layer away from the actual extension command implementations in order to simplify the syntax a little bit. So we also, in addition to the fields, we have 3 properties on the extension command base class, which is processing. So this indicates whether or not the command is processing async logic. If is processing is set to true, then the loader on the page will be displayed, and when it's set to false, we will disable the loader or hide the loader. We also have can execute, which indicates whether or not the command can execute based on the current page state. This will control the enabling or disabling of the app bar button. And finally, we have is visible, which controls whether or not the app bar button will be visible, and this can be turned on and off based on the different page to hide or show the app bar button. So beyond that, we have 2 abstract methods that need to be implemented by all of the custom command implementations. So that is the init method, which is called when the page is loaded for the first time to initialize the extension command, and the execute method, which will be executed when the command button is invoked or clicked. So I'll switch to the show journal one to show a little bit more about how it works in practice for the page specific. So here we're on show journal view, the declarations, and we can see show journal extension command base is extending extension command base with the show journal message type map. That's not necessarily important for the derived implementations of the commands, but just what's important is that it all extends from extension command base eventually. So in addition to all the functionality provided on extension command base, show journal extension command base will add page specific functionality, which is the handlers for various page events. So for show journal, we have the journal selection handler, the journal selection cleared handler, the receipt selection handler, and the receipt selection cleared handler. And so it was through these handlers that our sample code takes advantage of these page events to enable or disable the buttons on the app bar. So we can see here in the journal selection handler, we're adding this delegate function, which is going to call journal changed, which sets the selected journal on which is a field on our implementation, the products from that sales order and the customer, and it's going to set can execute to true, which is what we saw in the demo. And then we also can see here that in the journal selection cleared handler, we're clearing this all out and setting can execute to false, which is again what we saw in the demo. So with that, I think I'll turn it over to Roman, and he's going to talk a little bit about creating a new operation.
Thank you, Luke. So I will start talking about what operation handlers are, how do they look like, and how to actually find them in the samples if you guys want to really implement something. Okay, let's first start. As any extension point, you would look at the manifest. So let me just find the manifest first, I guess. Let me just hide a couple of things here. Okay. Okay. Just to clean things up a little bit. So again, if we're looking at the Retail SDK, we will have one sample in particular, which is a good example of operation handler, which is store hours sample. So in here, we can start with manifest. And manifest should contain several things. One of them is operations, where you're going to be able to add your own operation handler, where you're going to be able to specify which operation and operation handler for it. There is also one more item in here is operation request factory. This one is used by the button grid to execute the operation. And the reason is that usually the MPOS button itself, so if we navigate to home, the button itself on the home screen, for example, it doesn't really instantiate anything. But our factory would allow us to do that. So let's look at the code a little bit just to understand how it actually works. So let's start with operations, store hours, and in this particular case, operation handler is for operation ID 3001. Now, if you guys already familiar with this operation, operations are created in AX, then you can specify in the button grid, and then button grids gets pushed into MPOS, and then our extensions will be able to handle them. The first thing that will get executed is operation request factory, which will instantiate the request for a particular operation handler and basically will execute that. So here's the sample, and basically you can add additional information to a request if you want to read something dynamically. Let's say you want to get the current card and maybe pass it to your operation, like card ID or card line ID or something like that. So your factory would allow you to pass additional information to the operation request handlers. The operation request handler itself is, again, it's a pretty straightforward module where you import out of create, POS API create section, the operation base classes. In this case, we are extending operation request handler base. Now, all the modules, as always, if it is an extension, must be exported as default, extend, and do something. So in this case, operation handlers will have to have the execute async. All of them must be async because we really need to know when you guys done, and we really need to know. It must be async because you might have a network request, so you gotta be able to call us back and tell us, okay, we are complete. So that way we know you're done and we can continue doing something else. So, and as you can see, the sample, all it does is basically, if we take out all the complexity of the TypeScript, is basically the set timeout. Once that expired, it basically navigates to a to a specific view. So again, as any other extension, it's going to get the context through which you're going to be able to log things that you are interested in, informational or errors, and you're going to be able to fetch the resource strings. So if you have resources, you can localize some sort of message and again display it properly. So that's as far as the operation handlers. Now let's get back to the sample of the operation handler on the store hours view. So the store hours view, if you look at this, basically hitting this will execute the factory first, and factory will create a request for this request handler, and that request handler, all it does is times out and then navigates. Now in here, one little thing that I want to point out, so Luke already completed the whole UI part, but one important part I want to point out is that we have this dialog which you guys are going to be able to use as well, and it's called templated dialog. Templated dialog meaning that you can put whatever you want in it. It's any content, any way arranged, but there is the only limitation is obviously that its width. We're doing this because we have to follow our own patterns that we already kind of set in stone for us. It's set in stone for us, but you guys might ask for something else, but it's set in stone because we gotta fit these things in phones. So if you guys would like to put something custom, that's the way to do it. Templated dialog is your answer to any questions. In here you can specify buttons, 2 buttons. If you want more buttons, you can obviously put them in the content and specify more. In this case, in this particular sample, all it does is basically you can select a different time, and when you hit update, the request will be done to retail server to update that value. Now, in order to do that, additional things were added to the sample. Let's just wait for it to complete just to make sure it works. Takes a while. Okay, I guess it takes a while. Additional things were added to the project, and these are g.ts files. These files were generated by proxy generator tool, which you guys will be provided. This would allow you to generate the additional retail server methods that you guys might expose to do additional calls. So we exposing our APIs that we will provide you to call into server or do some work, and then you can create your own. So in this case, you can generate your own entities and requests, and you can execute them. So this thing will generate 2 things. One is entities, obviously, which introduce what data you want to pass back and forth, and the other one is requests and responses and request handlers. So request handlers would allow you to create a request, execute the request, and get response based on that request. So, and as soon as you add method on the server side, you're gonna get a request, response, and request handler. So you can instantiate and execute. In order to see a sample, again, you can navigate to, I guess, the dialog. I'm gonna try to see if dialog actually has that sample. Okay, and see, button click, and resolve promise. I guess the dialog will resolve it to the view. And if view stores view model, this is where the business logic is, and we need to find how this data gets sent to the server. I guess I was a little bit overconfident that I would find it here. Should be here. Here's this busy server store converter in this area. Cannot find it. Something changed in here. 1 second. Okay. Well, I'll come back to it at some point other time. Okay, so these are request handlers and data service. Okay, next on our list is triggers. So triggers is something that similar to events would allow you to kind of get a notification that something happened in MPOS. Now triggers require you to implement trigger handlers, and a good example can be found, I think we're adding them all over the place, but any project might contain it. You're basically going to need to extend, and you will extend triggers. You will need to specify which trigger. The triggers can be pre and post. So you would need to specify the name that you want to override. Those lists will be available in the documentation. And you need to provide the module that will handle this particular trigger type. Okay, to see the example, we again can open any of the trigger types. In this case, we are looking at pre-product sale trigger. Pre-product sale trigger would need to import, again, from extend section, from the triggers, product triggers, and we need to extend it. In this case, we are extending specific one, which is post-product sale trigger. Inside of it, again, you would need to have execute function, and inside of this execute function, you can do your work that you need to do. One note I got is that don't ever cancel post triggers. Some bad things happens, but overall, triggers can be canceled, but not the post ones. We're still working on them. So that's as far as triggers goes. These are pretty simple. It's a pretty simple concept. Consider them event handlers of sorts. It's just easier for us to implement triggers rather than throw in events or other things. Plus, it's a standard concept. So, and final thing that I will be covering is replaceable requests. So this is a new concept that we're introducing with this update. So we already discussed operation request handlers. So operation request handlers is handling an operation which came from EX. Now client request handlers are something that we just created inside of MPOS. There is no association with that request inside of the AX at all. So no one knows about this except the POS application and you guys. Those client requests, obviously you guys create the client requests. If we look at the samples, in the manifest of the sample, under create section, we should get request handler. So in this case, we're going to say, hey, there's a send email request handler, and it's under request handlers. Again, you would have request response and request handler. Inside of request handler, you would get execute async. You basically, to execute request handlers, you can use the context. So to get a good example of sending, sending email, it's a bar, right?
Send email request.
Mm-hmm.
I think we do it from an app bar command somewhere.
Yep. As always, good old search tool will help us, will save us. Let's see. Request handler, manifest. Request handler. Interesting. We created request handler and we didn't use it. Great. Post trigger.
Go to.
So the idea is that we have a request handler, client request handlers. Now the client request handlers is something that you guys can create using context. You can execute the request handler. Now the simple example, I can probably just display it quickly. So if in any of the views, for example, I need to execute this request handler, I would import this star as RQ H from, In this case, I'm importing request handler, so I need to go to relative path, yes, okay, request handlers, the / and in this case, this thing. Okay. Now we're going to do a quick with code. There we go. Much better. Not used. Good. Then we're going to import response, and we're going to import request handler. Response. Import request. Okay. In order to execute them, in every single extension, there is a context. So we basically can say this dot context would create new request, new request, send mail request handler, send mail request, which will take as a parameter something. We really don't care what it will take, but then we can say this dot context dot runtime dot execute async, and we will send request to it. So the concept is quite simple. You import and then you execute. So the context will give you again the ability to run stuff and get things that you may need, like localized strings. So that's as far as request handlers. Now we also implemented request handlers which are replaceable inside of MPOS. Those requests you cannot, so some of them can be executed, others are not, and we're kind of picking and choosing right now and discussing which ones would be available. And the idea is we will create request handlers. You can guys override them. So the good example for that would be inside of a payment. And sample is not ready yet. Let's see, show files. Payment sample. Let's include that one. Because we're running the project. Okay, let's right click again. One more try. Here we go. Okay. So what we have here, again, we can start with manifest. You will extend a component, and inside of extend now you basically have extension for request handlers. Request handler, all you do is specify in the module path. That's enough for us to understand which request you are replacing or trying to substitute. So by looking at the code, you basically can understand that we are importing from extend section the peripherals request handlers. Basically, a specific request handler that we're interested in this particular case, is payment terminal authorized payment request handler. If you were to extend that, you basically created successfully a substitute. Now, additional things that you need to import, but from a different section, in this case it's a consume, is a payment request and payment response. Authorized payment request and authorized payment response. The reason why I'm in two different sections is, as I mentioned earlier, you will be able to execute them as well. So if you were to able to execute, then they will be inside of a consume section. So we're keeping request and response and consume, but we're keeping the extensions inside of another section. So just to be clear, if you're trying to find something, keep that in mind. We do separate things by this section as far as what are you trying to do? Are you trying to extend things, or are you trying to consume things? In this case, we are extending authorized payment request handler. So if we're scrolling down, we basically can see that since it's a substitute, you will get the original request. You will be able to do something with it, additional data, maybe pass a card or something. And then one key difference between just regular client request handler and substitute is that you will be able to execute the original, so the one that was replaced from the beginning. That way you can basically see something that happens before execution started, and then you can process maybe after the execution completed. That way you can process before and after, maybe log, maybe send additional information and process it. That's a request handler replacement. And I think that's all I got for this. So I'm going to pass on to Mani. He will be closing up.
Yep. Thanks, Roman. So basically, like today we covered like how to, let me go back to the agenda slide. So we covered like how to create a new view using our store as sample, and then how to extend an existing view using the show journal sample, how to add like a custom column and app bar button. And then again, for creating a new operation, we use the store as sample, okay, which talks about like how to create the new operation. Similarly, for the trigger, we use like a different sample, like the suspend transaction receipt sample. And then last, for the override POS request handler, we covered the overriding the payment request. Currently, it's not possible to override all the POS request response handler. We have like a lot in the backlog based on the priority asked by the customers and partner. We are exposing the request handler one by one. But even I saw some questions on the IM. If you want to know like, hey, what are the request handler to be allowed to override, or what are the different triggers supported, or what are the views extendable, you can view all those information using our POS API. Or you can even go to the POS_API.d.ts file to view all those information. Okay. So one last thing I want to cover is like, so if you have any questions, or like if you need any new extensibility touch points which is missing in the product, or if you're not able to find it, please email to this alias, and then we'll be able to respond to you. Either say if there is already a sample available for your scenario, or if the extension point is missing, then we can reply back to you saying like, hey, these extension points will be available by this particular date. And also all the code shown today is like available part of the Retail SDK. So I think the app update will be coming out like today or tomorrow. So mostly you can view all the samples are part of the Retail SDK. Okay. So please feel free to send your questions and feedback. Also, we are planning to do the next session. So please send your suggestion or topic in which one you are interested, like a deep dive on, even you want like more deep dive on operations, like a new POS operation, or how to extend our views, or how to override. Please send us the feedback. Based on the feedback, we'll do the next extensibility session. Okay. Thanks everyone for taking your time and joining the session.
All right, thank you, McGunthin. All right, ladies and gentlemen, I'd like to bring your attention to a link that I posted in the messages panel. That's a link to a short survey for this web conference, and we ask that you please take a moment before logging out to access it. We hope that you found today's information helpful, and if you enjoyed today's web conference or have feedback on how we can provide you with a better event, this is your chance to let us know. The survey scores are on a scale from 1 to 5, with 5 being the highest score possible. And that is going to conclude today's web conference. Attendees may access the web conference recording via the same registration link used to attend today's live broadcast. I'd like to extend a big thank you to our presenters, McGunthin, Roman, and Luke, and thank you, audience, for logging in and joining us today.